Integration applications, projectiles, example 2. A particle with a mass m is projected at an angle alpha to the horizontal with an initial velocity u in a medium of resistance mkv. Here k is a constant and v is the velocity of the particle at any given time. Obtain an expression for the time taken for the particle to reach the maximum height Tmax. The downward force on the particle is equal to mg plus mkv, mass times gravitational constant plus the resistance mkv. Using Newton's second law for the motion of the particle, we can write P equal to mf or P equal to m dv by dt. The acceleration is f is given by dv by dt. And actually, if you look at the forces on the particle, there's one force downward, mg plus mkv, and one force upwards. Actually, this acceleration is towards down, but if you take a opposite direction, it is negative acceleration or deceleration. So therefore m minus m dv over dt equal to mg plus mkv for the force balancing. Then now we simplify further to get g plus kv equal to minus dv over dt, and when you take dt into one side, dv into the other side, you get this differential equation. Now we can integrate both sides to obtain this equation. 0 to Tmax dt is equal to negative, and here we need to find out the vertical velocity at the beginning. So we have a projectile which starts like this with an angle of alpha to the horizontal with a velocity u, and therefore the vertical velocity is equal to u sine alpha, and we need to find out the maximum height it will reach, where the velocity becomes 0 at this point. Therefore our integration constants here u sine alpha to 0. The limits of the integration is from u sine alpha to 0. That means vertical velocity at the beginning is u sine alpha, at this point becomes 0, and the time 0 to the maximum time Tmax. So after further simplification, you get this equation: minus 1 over k u sine alpha to 0 g over k plus v dv. These are two constants, but v is a variable. Now we can look at this as a function of v. If v equal to g over k plus v, then if we differentiate fv, we get f dash v, which is equal to 1. Differential of a constant is 0 and v will become 1. Now we need to look at it like this. So we have 0 to Tmax dt, this one, but this function is actually fv, and fv over f dash v, which is actually a general equation that you can find in integration, where if we have fx over f dash x, you can write it as ln fx e to b. So therefore this term here can be written as ln fx equal to g over k plus v, in this case fv. So limits are from u sine alpha to 0. So basically what we did here was to get v as a individual constant, individual variable here, to get the equation in this form. Now we can further simplify. Basically you can substitute the limits of integration Tmax minus 0 when you substitute those two values, and then we have to substitute velocity from 0, final root is 0, the initial velocity was u sine alpha. So you substitute those two values, you get this one, and when you take this into one equation, 1 over k ln g over k, and this negative sign will bring this term to the denominator, and negative of that. So since it's negative, this term can be inverted. Basically g over k will come down and g over k plus u sine alpha will go up, and this is the final answer to this question.